Welcome to grade 11 chemistry. What we're learning about today is how to write multivalent compounds. So that's our learning goal for today, is to be able to write the formula and name the compound for multivalent compounds. So if we look at our naming chart, just to recall, we have two types of bonds, ionic and covalent. They both have two different naming methods. We're going to learn ionic first. We learned binary last lesson. Today we're going to talk about multivalent. And next lesson we're going to talk about polyatomic. So to start, when we have to write a formula for the multivalent compounds, we have to write the symbol of the metal first. We then use the Roman numeral in the name and put the charge above the metal. We then write the symbol of the nonmetal second and put the charge above it. And we balance the charge or cross over so the overall charge is neutral. It's important to know that multivalent means many different charges, okay? And nonmetals cannot be multivalent. Only metals. There's no such thing as multivalent nonmetals. It's only multivalent metals. So we have some examples here. And you can take a look at iron. It says iron, Roman numeral 2. This number 2 represents the charge on the metal because you have to specify what charge it has. If we look at our periodic table, we will see that iron can have a 2 or a 3 charge. So when we look at our periodic table, we actually find iron located here, and its charge is actually written directly above it in the upper right corner, and it actually says 2 or 3 when you zoom in on it. Now the yellow are my non-metals, and all the pink ones are all possible. They are all possible multivalent compounds. And the only really way to check is to zoom in. Now iron has a 2 and a 3, so therefore it's multivalent. Cobalt is also multivalent because it has a 2 or 3, and so on. I'm going to show you one that is not multivalent. If we take a look at cadmium right here, it actually has just one type of charge above it. It only can have a 2 plus charge, so therefore it is not multivalent. So not everybody in this pink zone is multivalent, but anybody with multiple charges will actually be considered to be multivalent. For example, vanadium it's got 2, 3, 4, 5, but zirconium is not, it only has a 4. So this is the general zone. This pink zone here is where they are found. So we see that iron, again, in our previous example, can have a 2 or a 3 charge. So what we do to answer this is we know iron. We write the symbol for iron, which was Fe from the periodic table. And it has a 2 plus charge. Then what we're going to do is that 2 comes from this Roman numeral 2. I know what it is. I don't even have to look at the periodic table. It says it's a 2. Then we write the symbol of my nonmetal, which is Cl. And if we look, it should be a -1 charge. It's in group 7, so therefore it's -1 charge. Now all we do is we cross over and reduce, and the answer will be FeCl2. Okay? That is neutral, and that's it. So let's try lead 4 oxide. So again, we find the symbol for lead on our periodic table. It might be hard to find, but you can find it. It's Bb. It tells me its charge. It's 4 plus. We look at oxygen on the periodic table. It's located in group 6A or group 16. And it's got a 2 negative charge. Nonmetals cannot have multiple charges. So we cross it over, and it says Pb2O4. Remember, we have to neutralize this or minimize this. So we can actually divide both of these numbers by 2. The lowest common denominator is PbO2. That is our answer for both our formulas. So we'll go over some examples. Hope that made sense. Okay, next thing we're going to do is learn how to write the names for multivalent ionic compounds. So what it says we're supposed to do here is to determine the known charge on the nonmetal and use this to find the charge on the metal to make it neutral. Write the metal first, followed by the charge that was used in the Roman numeral. Write the name of the nonmetal second with the ending of "ide." So let's give an example of this to see if it makes sense. Okay, so our first example, number 1, says SNO. So to determine the known charge of the nonmetal and use it to find the charge on the metal to make it neutral. So first of all, we know the charge on the nonmetal. Let's look at it. We know oxygen right here is in group 6A or group 16. It has a 2 negative charge. So therefore we can put that charge right up here. And it says, and use this to find the charge in the metal to make it neutral. Well, I have 1 SN, so therefore the charge on it must be 2 positive to be neutral. Okay, so therefore my answer is going to be SN, which is, so I look at SN and I see that it can have a 2 or a 4 charge. Its name is tin, so we said it was going to have a 2 charge. That makes sense. It's tin. So my answer is going to be tin 2 oxide. So it's TiN, Roman numeral 2. Again, this 2 represents the charge on the metal. Oxygen can only have 1 charge, so it's tin 2 oxide. Take a look at the second one and see if you can do it as well, okay? And if you did it correctly, the answer should be lead 4 chloride. And we know this because chlorine is a group 7 element. It has a -1 charge. So therefore you have 4 of them. So 4 times -1 is 4 negative. We have 1 lead, and that means its charge must be 4 positive to make it neutral. Remember, an ionic compound's the minimum amount to be neutral, so that's it. That's the answer there. I'll leave you with one more before we go. And the way that we do this one is SN2C. So what I would even start is, guys, is I'd look for the element names, and we know this was tin before, okay? And we know that's carbon, so that's going to be carbide, because the ending always ends in IDE. And we need to include Roman numerals, because when we look at tin, we see it's SN, and SN is located, where are you? Right here. And it can have a 2 or a 4 charge. Okay, so we need to decide if it's going to be a 2 or a 4 charge. And to decide that, we have to look at carbon, the nonmetal. We know this guy has a 4 negative charge because it's a nonmetal. It's going to have a negative charge. So therefore, tin has a 4 negative. We have 1 of them. Okay, so 1 times 4 is 4. So my total negative charge is 4 negative. And so therefore, I have to have a total positive charge of 4. Well, this is kind of interesting because we have 2 tins and we have to have a total positive charge of 4. If I have 2 ions, that means that each individual ion will have a charge of 2. So this guy here is going to be tin 2 carbide. And the reason is that you're writing the charge on the individual ion, okay? Not the total negative, or not the total positive charge, but the charge on the individual ion, okay? So charge on individual. Whoa, that's ugly, guys. Individual. Whoa, I don't know what's happening here, guys. But it's not working. So anyways, that's it. So it's the charge on the individual ion. Looks like my daughter wrote that. But anyways, you guys have a nice night. I hope you learned how to name multivalent stuff and write the formula. If you have questions, we'll talk about it tomorrow. That's it.
Oh, please, don't you rock my boat.